Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 5, Section 4, Solving Quadratics by Taking the Square Root of Both Sides. So we'll start by listing the steps in words in the list format. In order to solve quadratics by taking roots, you want to isolate the squared expression. It could just be an x squared, or it could be something in parentheses squared. When you have the squared part isolated, you do take the square root of both sides, and then you simplify the radical. So just to clarify, when you use this method, the best way I can say it is that it would be used when you don't have an x term. Like if you had x squared plus 73 equals 0. This can't be factored. The only way to solve it then is to isolate this x squared and then square root both sides and simplify the radical. So this is used when you do not have an x term. Let's look at example 1. Step 1 says to isolate the x squared. This x squared is already isolated. It doesn't have any numbers around it. So we can go ahead and proceed to step 2 of taking the square root of both sides. So I take the square root of x squared and the square root of 256. Now the square root of x squared is just x, because if you have a number and you square that number and then you square root that number, you're right back to where you started from. And I don't know if you have the perfect squares memorized, but I'd like you to memorize them up to 15 squared, and this 256 just happens to be 16 squared. So this answer is plus and minus 16. Remember, with a quadratic, you are looking for two answers, and you do have to state both of them. In example 2, the x squared is not isolated yet, so that needs to be our first step. So first we're going to add a 100 to both sides, and then we're going to divide both sides by 3. So I have 100 over 3. Leave it in fraction form because decimals just get too messy and we lose all our accuracy. So now that the x squared is isolated, now we do go ahead and take the square root of both sides. The square root of x squared, of course, is x. And I'm going to split this up because that's visually more helpful to me to see the square root of 100 over square root 3. And then we notice that we do have a perfect square in the numerator, so that's nice. Square root of 100 is 10. And now we have this square root 3 on the bottom. And hopefully you notice that I did forget my plus minus sign, so I'm going to put that in the front here. We need to rationalize this. However, we cannot have the square root of 3 in the denominator because we cannot divide by an irrational number. So we're going to multiply this fraction by the quantity of 1, but we're going to pick that 1 very strategically that will help us. We're going to write the 1 as square root 3 over square root 3, and now we can write our final answer, plus minus 10 square root 3 over 3. The next concept we need to learn is about imaginary numbers. They call it the imaginary unit here. We just denote it by the letter I, small I. And mathematicians needed a way to work with negative square roots because we encounter them in our problems, and we just needed a tool to work with them and get to an answer. So the way I understand it, basically they made this up. It's a definition. They defined I to be the square root of negative 1. So it's just defined that way. And then if you square both sides of that equation, you would get I squared equals negative 1. Now, I will leave these up on the whiteboard for quite a while, but eventually you'll just want to memorize this and know this so that we can use it when it pops up in one of our answers. This square root property is sort of Captain Obvious, but we'll just talk about it. When you have x squared equals any number k, depending on what this number is, we can tell what kind of answers we're going to have. If k is bigger than 0, that is, if it's positive, then x, the answer would be two real numbers because they're positive roots. If this turns out to be 0, then x just has one real answer, and because the square root of 0 is 0, and 0 isn't positive or negative, it's neutral, it's just itself, so that's why there's one real answer. And in step 3 here, if k turns out to be negative, meaning it's less than 0, then we have two complex. In other words, the answers have I in them. And when an answer has I in it, it's called a complex number because often there's an imaginary part and a real part. So that's just 3 possibilities that can happen when we're solving the quadratics. So let's look at some examples where we will have some negative square roots. Again, we notice there's no x term, so we're going to use the square root method. We're going to start by subtracting 45 from both sides. Now the x squared is isolated, so we take the square root of both sides. So x is plus or minus the square root of negative 45. Now this negative sign right here is represented by negative 1, and we know that the square root of negative 1 is I. So the first thing I'm going to do is pull the I out. Oh, that sounded kind of gross. Pull the I out. Anyway, put the I in front. So the second thing to do is to look for any perfect squares in the 45, and I'm hoping you see that 9 times 5 is 45. So we need to pull out that perfect square 9. So this square root of 9 is 3, so we have 3i in front, and underneath the radical we have square root 5. So that's the two answers to this quadratic. Part B here, again, we start by subtracting the 126 from both sides. Take the square root of both sides, so we have plus minus the square root of negative 126. We're going to have to do the I. The square root of that negative sign is an I. And if we look for a perfect square, we'll see that 9 times 14 is equal to 126. So the square root of 9 comes out as 3. The square root of negative 1 comes out as I. And 14 is left under the square root symbol. All right, now you have the knowledge you need to do section 5.4, so have fun with math.